This is cables problem number 1, and it involves a power station and a factory and trying to find the optimal cost for laying a cable from the factory to the power station. It involves the cost of $25 per meter to run the cable under the river and $20 per meter to run the cable along the land. So the question is to find this distance x such that you should turn off and head toward the power station. If you just go straight from the factory to the power station, that's the shortest distance, but it also costs the most money for every meter of that distance because all of it would be under the river. And if you wait till you get all the way across the power station so that you can lay the cable at $20 per meter for the most amount and then go across, then you're going the furthest distance. 200 meters plus 60 meters would be 206 meters of wire. So you're trying to figure out where the optimal spot to cut across the river is so that the cost will be the cheapest. So the constraint on this is a little bit tricky. I think it's almost easier to not really think of a constraint. You just need to find the cost, and the cost equation is $20 per meter for anything along D1 plus $25 per meter for any length along D2. And then you need to get D1 and D2 written in terms of x. So you could say that D1 is equal to 200 minus x, because it's just this linear distance here, and D2 involves the Pythagorean theorem, the square root of 60 squared plus x squared. And so then your cost equation as a function of x is equal to 20 times 200 minus x plus 25 times the square root of 60 squared plus x squared. So now that equation will give you different costs when you vary this distance x, and you want to find out what the distance x is when the cost is the cheapest. So you'll end up having a graph over here that has a minimum, and you're looking for the place where the graph has the lowest cost. In order to figure out how to scale the window to be able to see this, we need to make a guess. And I think these ones actually have a nice easy guess because you know that x has to be less than 200 because this total distance here is 200. So we could guess, I don't know, say 70. We could guess 100, that would be fine. So if I guess 70, then y is 130, and the cost would be this equation. So let's bring this up, and we'll have y equals, we'll have $20 times distance 1, which is 200 minus x. 200 minus x, since x we guessed is 70, plus 25 times the square root of 60 squared plus 70 squared. $4,905. So That's good information. So now we know that the cost of laying that cable is $4,905-ish if you round up. And this is just for estimating the size of the window, so it's okay to round here. And this is cost. So now we know that this can vary. It could go all the way up to 200, so I may as well put that there. And then the cost, if that's $5,000, my guess is that's actually a pretty typical cost. So generally we double that, but I'm going to just go up to say 8,000. I don't know. Then let's graph it. So we'll go to y equals, and it is 20 times 20 minus x plus the square root of, plus 25 times the square root of 60 squared plus x squared. Alright, I think that looks good. And then we'll set our window 0 to 200, and y scale, say 20, 0 to, what did we say, 8,000? And you can do this in thousands. So yeah, 8,000 was a little high. I'm going to cut that down to maybe 4,000. Looks a little better. And then we are looking for the minimum of that function. And you could do a little double check to make sure things are working right. Second, calculate the value at 70. And something is wrong. Oh, I see it. It's not 200. It is, it's not 20, it's 200 right there. So then that's probably why our window might actually need to be 8,000. There we go. Good recovery. Okay, so second, calculate minimum. Enter. Enter. And the minimum is when x is 80 and y is 4,900. And what I started to do, which allowed me to catch my error, was to double check to make sure that when I did second calculate value at 70, that I got 4,900 and about 5, which is what I had written down in the table there. That's how I knew I had that mistake in entering the function. So that's always a good idea. Once you've taken the trouble to make a guess, then check it on the calculator by second calculate value to make sure that everything's fitting together correctly. Alright, so do that one more time. Minimum. Enter. And move to the right. Enter, enter. So it was 79.99999 is trying to be 80, and the y is 4,900. So I have a graph that looks about like this, and 80, comma 4,900, and remember that that is the distance x and the cost of $4,900. So my answer, how should the cable be placed in order to minimize the cost? So x is 80 just to be super specific, you could say D1 then must be 120. D2 we could figure out, and the overall cost is $4,900. And D2 would be the square root of 60 squared plus 80 squared. Which is 100. I should have known that. And so these are all meters, and the cost is $4,900. Now, I think it would also be interesting to think about what's really going on in the problem and what it would be like if you actually, how much would it cost if you just ran this all the way here, such that basically x is 200, or this whole length is under the river. So if it was all under the river, then this would be 60 squared plus 200 squared. And 60 squared plus 200 squared, square root of, is about 208 feet. And then if that all costs us $25, then if you just went straight from the factory to the power station, the total cost would be $5,220. So this was 208 meters, and the cost would be $5,220 roughly. 220. And then if instead you went all the way along here, 200 meters along the shore, and 60 meters to the power station, then that cost would be, I'll do that right here, that cost would be $20 times 200 plus $25 times 60, and notice the total distance is 260 meters, whereas this, the total distance was 208 meters. And on this, the total distance is 220 meters. So 260 meters is definitely further, but you get to lay more of the cable at $20 instead of $25. So 20 times 200 plus 25 times 60 gives me $5,500. So the optimal cost is $4,900, and then the extremes, the endpoints of the function, if x is 0, you get 5,220. No, if x is 200, you get 5,220, and if x is 0, you get 5,500. And you could check that on your graph as well. Second, calculate value at when x is 0. That would be the green case here. We get 5,500. And if x is 200, then we get the 5,220.